Good afternoon, students. So in the last class, I just gave the introduction. Can you hear my voice now? Is my voice is audible? Okay. Okay. The standard form of the homogeneous linear PDE. This is a form A naught dou power n z by dou x power n. This is the equation 1 is the standard form of the homogeneous linear PDE. And you can write the equation 1 in the form of f of d comma d dash into z equal to f of x comma y. So our aim is to find the solution of equation 2. The solution of equation 2 consists of two parts. One is a complementary function, another one is a particular integral. Okay, now first you should find the complementary function. So for this, if you need to form auxiliary equation. So first you should replace d by m and d dash by 1 in f of d comma d dash. You will get a auxiliary equation. So you should find the roots. If all the roots are distinct, then the complementary function is f1. F1 is the arbitrary function. F1 of y plus m1x plus f2 of y plus m2x up to fn of y plus m1x. Okay, now for equal roots, so out of n roots, all roots are equal. So for equal roots, first you should write f1 of y plus mx plus x into f2 of y plus mx up to x power r minus 1 into fr of y plus mx. So this is for equal roots. The remaining is for distinct root. Fr plus 1, y plus mr plus 1 into x, and so on, plus fn of y plus mn into x. Okay, so here only for equal and distinct roots. So for imaginary roots, we will write in differential equations in the form of e power alpha x into a cos alpha x plus b sin alpha x, b sin beta x. Okay, but here we will consider the complex roots is also distinct root. Suppose if you have 1 plus I and 1 minus I, so you will consider 1 plus I is 1 plus I and 1 minus I are distinct root. Okay, to find the PI, so I think yesterday I explained how to find the PI. The first method is the right hand side, that f of x comma y is e power ax plus by. So then how to find the PI for this function? So you should replace d by a and d dash by b. So only if the denominator is f of a comma b is not equal to 0. Suppose the denominator is equal to 0. Then sometimes you can write the denominator in the form of d minus some constant into d dash whole power r into whole power r. This is actually f of d comma d dash. So if it is power r, then this is equal to x power r divided by r factorial into e power ax plus by. So sometimes you cannot write like this. So those time you should multiply the numerator by x and differentiate the denominator with respect to d. Okay. So if you solve the problem, you can understand these types of situation. Okay. Type 2. Type 2 is a function. The right hand side function is either sine of ax plus by or cos of ax plus by. So in this case, you should replace d square by minus a square. Okay, actually this is not equal to, you don't write like this. Okay, so this is incorrect. So minus square is only for a, and d dash, you should replace d dash by minus a into b. D dash square, you should replace this by minus b square for both the case, sine and cos. So minus a square minus ab minus b square. So this is you can use this only if the denominator is not equal to 0. Suppose the denominator equal to 0. So then again you should multiply the numerator by x and differentiate the denominator with respect to d, or otherwise you can use this formula. Okay, this is equal to minus x by 2a into cos of ax plus by. Similarly, for right hand side is cos of ax plus y. Okay, so now we will go to directly problem. Then suppose if you need this procedure, then we will come back again. Okay, first problem, solve 9d square plus 6d d dash plus d dash square into z is equal to, the right hand side is the exponential, e power x plus e power minus 2y whole square. So this is type number 1. So first you need to find a complementary function. So for this you need to form the auxiliary equation. So first replace d by m and d dash by 1. So if you replace d by m, you'll get 9m square plus 6m into d dash by 1 plus d dash is 1. So 1 square is 1 is equal to 0. So you can write 9m square plus 6m plus 1 is equal to 3m plus 1 whole square. So the roots are minus 1 by 3 and minus 1 by 3. The roots are equal here. So if it is equal, then I gave the procedure how to find the complementary function. So complementary function is equal to phi 1 of y minus y minus 1 by 3 into x plus x into phi 2 of y. Here I think minus. Here also we should write minus minus 1 by 3 into x. So pi equal to 1 by 9d square plus 6d d dash plus d dash square. The right hand side is what? E power x plus e power minus 2y whole square. Okay, now a plus b whole square, a square plus b square plus 2ab term. Now split this pi into pi1, pi2, pi3. So pi1, you have this operator into e power 2x. So this is pi1. So you have only e power 2x. So I want to write in the form of e power ax plus by. So a equal to 2 and b equal to 0 here. So you should replace d by a equal to 2, and d dash by b equal to 0 here. So if you replace d by 2 and d dash by 0, we will get 1 by 9 into d square. D square is 2 square plus 6 into d is 2, d dash is 0 plus d dash is 0 into e power 2x. So denominator is what? So this is 0, this is 0, 9 into 4, 36. So e power 2x by 36. So this is pi1. pi2. So please check the previous slide. That is the second. Okay, the second e power minus 4y. Okay, e power minus 4y. So 1 pi2 equal to 1 by 9d square plus 6 into d dash plus d dash square into e power minus 4y. So again, you should write e power minus 4y in the form of e power ax plus or minus by. Okay, so here a equal to 0 and b equal to minus 4. Replace d by a is 0, d dash by b is minus 4. So if you replace d by 0 and d dash by minus 4, so you'll get this is 0, this is also 0, d dash is minus 4. So 1 by 16 into e power minus 4y. So this is PI2. PI3, that is a 2a bit term. So here you need to replace d by a is 1 here, d dash is by b is minus 2. So just replace d by 1. So 9 into 1 square plus 6 into 1, d dash is minus 2. So minus 2 whole square. Okay. So if you simplify the denominator, you'll get 9 minus 12 plus 4. So 13 minus 12 is plus 1. So PI3 is 2 into e power x minus 2y. The general solution is z equal to CF plus PI1 plus PI2 plus PI3. So this is the procedure. So problem number 2. Solve d power 4 minus d dash power 4 into z equal to e power x plus y. So first you need to find the CF. For this, you should find the auxiliary equation. So replace d by m and d dash by 1. So that is the first step. So m power 4 minus d dash is 1. So 1 is equal to 0. You can write m power 4 is m square whole square minus 1 square equal to 0. So this is of the form a square minus b square. You can write this is a plus b into a minus b. So m square plus 1 equal to 0 implies m square equal to minus 1. So m equal to plus or minus I. Similarly, m square equal to minus m square minus 1 equal to 0 implies m square equal to plus 1, and hence m equal to plus or minus 1. So there are 4 roots because this is the fourth order differential equation. So all the roots are distinct here. Plus 1, minus 1, plus I, minus I. So the complementary function is pi 1 of y plus 1 into x, that is x, plus pi 2 of y minus x, plus pi 3 of y plus ix, plus pi 4 of y minus ix. So we got the CF. Now we need to find the PI. The right hand side is in the form of e power ax plus by. So here a equal to 1 and b equal to 1. So we need to replace d by 1 and d dash by 1. So if you replace like this, the denominator is 1 minus 1, so 0. Then you need to multiply the numerator by x and differentiate the denominator partially with respect to d. So you will get, so I'll write 1 by 0. Okay, 1 by 0 into e power x plus y. Okay, now pi equal to, you should multiply by x here and differentiate the denominator with respect to d. So you have d power 4 minus d dash power 4. If you differentiate with respect to d, you'll get 4 d cube. This is 0. So x by 4 d cube, 4 d cube into e power x plus y. So again, you need to replace d by a, and if you have d dash, then d dash by b. There is no d dash here, so only you have d only. So replace d by 1. So if you replace d by 1, you'll have x by 4 into e power x plus y. So this is your PI. So I explained 2 problems. So if you have any doubts in these 2 columns, you can ask me. Otherwise, I'll go to problem number 3. Okay. The problem 3 is d cube minus 6 d square d dash plus 12 d dash square minus 8 d dash cube into z equal to, again the right hand side is 1 plus e power 2x plus y whole square. So auxiliary equation. So in auxiliary equation you should replace d by what? M and d dash by 1. So you'll get m cube minus 6m square plus 12m minus 8 equal to 0. So this is of the form a minus b whole cube, not whole square. So m minus 2 whole cube equal to 0. So m equal to 2, 2, 2. So the roots are repeated. So the complementary function is f1 of y plus 2x plus x into f2 of y plus 2x plus x square into f3 of y plus 2x. So here also I am going to split the PA into 3 parts. One is for a square term, another one is for b square term, another one is for 2ab term. So a square, this is b square term, this is 2ab term. So you have 1. So you can write 1 is in the form of e power 0x plus e power 0y. So you should replace d by 0 and d dash by 0. So actually d by a is also 0 and d dash by b is also 0. So if you replace d and d dash by 0, the denominator is 0. So then you should multiply the numerator by x and differentiate the denominator with respect to d. So 3d square minus 12d into d dash plus 12 d dash square, this is 0. So you'll get this term. Now again replace d and d dash by 0. So again the denominator is 0. So you need to multiply again the numerator by x. So x into x square. So you'll get x square 6d minus 12d. So x square divided by 6d minus 12d dash. Okay, again replace d and d dash by 0. I got 0, the denominator. So multiply here again by x. So x cube by differentiate the denominator with respect to d, you get 6. So x cube by 6. So this is 1. So this is pi1. Next to pi2. So I'm writing here. You can check it. So here I write as it is given the question. Now you can write this is d minus d dash whole cube. If it is possible, you can write. Okay. So I'll write f of d comma d dash is d minus 2 d dash whole cube. This is the right hand side function. So you can check it here. If you replace d by 2 and d dash by 1, because a is what, 2 and b is 1, you'll get the denominator is 0. So I already told that if this is a case, then you can write x power r by r factorial into the right hand side function. Here 3, you have 3. Okay, so and hence x power 3 by 3 factorial into 2 into e power 2x plus y. So this is the final answer. We'll check it. So I think 2x cube yeah 2x cube divided by 3 factorial into e power x plus y. Otherwise you can do step by step like this. You can check it here. So if you use this rule, actually I gave the rule here. So this is the rule. So 1 by d minus a by b into d dash power whole power r into e power ax plus by the denominator is 0, then if it is possible to write f of d comma d dash in this form, then you can write this is equal to x power r divided by r factorial into the right hand side function. So okay, I think we are discussing PI2. So, but I'm not using this result. I am doing by step method. So just a 2. If you differentiate with respect to d, you'll get what? First you are replacing d and d dash by 2 and 1. The denominator is 0. Again multiply the numerator by x. Differentiate the denominator with respect to d. So then you'll get 3 into d minus 2d dash whole square into e power 2x plus y. So again you should replace d by 2 and d dash by 1. So you'll get 2 minus 2, 0. So again you need to multiply the numerator by x. So 2x square. If you differentiate the denominator, you'll get what? 3. 3d. If you differentiate 3d, you'll get 3. So this is 0. So 2x. Okay. So 2x square. 2x square. 2x square. Okay. By 6 into d minus 2d dash. 6 into d minus 2d dash. Okay, again if you replace d by 2 and d dash by 1, the denominator is 0, and multiply the numerator by x and differentiate the denominator with respect to d. So 2 by 6 is, okay, you can write this is 1 by 3 into x cube. If you differentiate this, you'll get 1. So e power 2x plus y. So please check it, the next slide. So x cube by 3 into e power 2x plus y. So this is your PI2. So if you use that result, you can immediately get this result. Okay, now PI3. PI3, here I am using that result. You can check it. So 1 by d minus 2d dash whole cube into this is a right hand side function. If you replace d by a is 4, and d dash is by b is 2. So 4 minus 4, 0. R equal to here 3. So this should be equal to x power r. R is 3 by r factorial. The 3 factorial into the right hand side function. So x cube by 6 into right hand side function. This is PI3. The general solution you should write z equal to CF plus PI1 plus PI2 plus PI3. Okay. So fourth problem. Solve d square minus 3d d dash plus 2 d dash square into z equal to 2 times cos h of 3x plus 4y. Okay, now auxiliary equation. So just replace d by m and d dash by 1. So m square minus 3m plus 2 equal to 0. If you factorize, you'll get m minus 1 into m minus 2 equal to 0. So m equal to 1 and 2. The roots are distinct. So then the CF is f1 of y plus x, because 1 and 2 are the roots, plus f2 into y plus 2x. So CF is over. And what is the right hand side function? 2 times cos h of x. Okay, you know that cos hx is equal to e power x plus e power minus x divided by 2. So 2 times cos hx is e power x plus e power minus x. So e power, so this is x, this is minus x. So again, I split into 2 pi, so pi1 and pi2. So just you should replace d by 3 and d dash by 4 you will get PI1. Similarly, in PI2, you should replace d by minus 3 and d dash by minus 4. You will get PI2. So you can easily check it. The final answer is Z equal to CF plus PI1 plus PI2. So up to this, the 4 problems comes under category type 1. So now type 2. Type 2 is either sine of AX plus BY or cos of AX plus BY. Okay, first I'm taking the right hand side function is cos of x minus 3y. Okay, the auxiliary equation is again you should replace d by m and d dash by 1. So m square minus 2m plus 1 is equal to 0. So m minus 1 whole square equal to 0, m equal to 1 and 1. The roots are equal. The roots are equal. So and hence the complementary function is pi 1 of y plus x and x into pi 2 of y plus x. Okay, now the right hand side function is what? Cos of x minus 3y. So 1 by d square minus 2 d dash plus d dash square. Okay, here the rule is you should replace d square by minus a square. So minus a is 1. So 1 square equal to minus 1. So and the d dash by minus a into b equal to minus a is 1 and b is minus 3. So minus into minus plus 3. And d dash square by minus b square. So minus and b is minus 3. So minus of minus 3 whole square. That is minus 9. So here 1 by what is d square? You should replace d square by minus 1 minus 2 into d dash by 3 and d dash square by minus 9 into cos of x minus 3y. So the denominator is 10, 16 minus 1 by 16 into cos of x minus 3y. So and hence the general solution is Z equal to CF plus PA. Okay, now here the problem is what? Right hand side is what? Cos 2x into cos 3y. Okay, now d square minus 4 d dash square into z. The auxiliary equation is if you replace d and d by m and d dash by 1, you will get m square minus 4 equal to 0. So this implies m square equal to 4, m equal to plus or minus 2. So the roots are distinct. So the complementary function is pi 1 of y plus 2x and pi 2 of y minus 2x. Okay, now the right hand side function is cos 2x into cos 3y. So now I am going to use the formula for 2 cos a cos b. So 2 cos a cos b is cos of a plus b plus cos of a minus b. So here 2 is missing. That's why I'll divide by 2 here. So PI1 is 1 by 2 into 1 by d square minus 4 d dash square into cos of 2x plus 3y. So now you should replace d square by minus a square. That is equal to minus a is here 2, so 2 square. So replace d square by minus 4. Similarly, d dash square equal to minus b square is equal to minus b is 3, so 3 square. So minus 3 square is minus 9. So 1 by 2, 1 by d square by minus 4, d square by minus 4, minus 4 into d dash square by minus 9 into cos of 2x plus 3y. So 1 by 2, here this is what? 36 plus 36 minus 4. So 1 by 32 into cos of 2x plus 3y. So 1 by 64 into cos of 2x plus 3y. Okay, now Pi2, the only difference is what? Here minus. Here minus. So again, d square equal to minus a square minus a is 2. So 2 square, that is equal to minus 4. D dash square equal to minus b square. So minus b is minus 3 whole square. Again, you get what? Minus 9. So here also what? D square equal to minus 9. Here also d square equal to minus 9. So the final answer is same. The constant is same. You can check it. So 1 by 2, 1 by d square equal to minus 4. Minus 4 into d dash square is minus 9 into cos of 2x minus 3y. 6 minus 4 is 32 into cos of 2x minus 3y. So Pi2 is 1 by 64 into cos of 2x minus 3y. So I need Pi, so that is equal to Pi1 plus Pi2. So that is 1 by 64 into cos of 2x plus 3y plus 1 by 64 into cos of 2x minus 3y. So I'm taking commonly 1 by 32. So remaining is what? Cos of 2x plus 3y plus cos of 2x minus 3y divided by 2. So 1 by 32. This is actually, again I use the formula. You can get cos A, cos B. Actually, this is actually cos of A plus B plus cos of A minus B equal to 2 cos A cos B. So 2 is here. So the final answer is 1 by 32 into cos 2x into cos 3y. So please note down this answer. 1 by 32 into cos 2x into cos 3y. So we will check it. There is one shortcut method. Okay. So here I will do here the shortcut method. I will try. Instead of finding Pi1, Pi2, okay. So actually here replace directly by d square by minus 4. Please check it. D square by minus 2 square minus 4 into d dash square. D dash square is minus. Okay, there is one more minus. Okay, minus 4 into minus 3 square into cos 2x into cos 3y. Cos 2x into cos 3y. So you'll get 1 by minus 4 plus 9 into 436 into cos 2x into cos 3y. So you'll get 1 by 32 into cos 2x into cos 3y. So I think we'll get the same answer. Please check it. So 1 by 32 into cos 2x into cos 3y. You can use the result only if you can use this idea only if you have cos or sin, then only you can use this result. And also you can use only this result only if you have d square and d dash square. If you have d dash term, if you have d dash term, the denominator, you can't apply this idea. Okay, the shortcut method. So you can use only if the right hand side is cos or sin. You don't apply whether you have sin cos or cos sin. Similarly, you can't use this idea, the shortcut method. The denominator contains the term d dash. Okay. So I think this problem is over. So the final solution is Z equal to CF plus PA. Okay, next problem. D square minus 3D D dash plus 2D dash square into Z equal to sin X into cos Y. So here sin and cos, then you can't use that previous shortcut method. So the auxiliary equation is m square minus 3m plus 2 equal to 0. So you should replace d by m and d dash by 1. If you factorize this, you will get m minus 1 into m minus 2 equal to 0. So the roots are 1 and 2. Here it is a distinct root. And hence the complementary function is pi 1 of y plus x plus pi 2 of y plus 2x. So next we need to find particular integral that is equal to 1 by d square minus 3d d dash plus 2d dash square. The right hand side function is the form of sin a cos b. So 2 sin a cos b is sin of a plus b plus sin of a minus b. So here 2 is not here. So 1 by 2 into sin of a plus b, sin of x plus y plus sin of a minus b, sin of x minus y. So again you need to split into two pi's. One is a pi1. This is pi1. pi2 is 1 by 2 into sin of x minus y. Okay. So first we will consider pi1, that is equal to 1 by 2, 1 by d square minus 3 d dash plus 2 d dash square into sin of x plus y. So we need to replace d square by minus 1 square and d dash square by first you should write in this order. Okay, d square and then d dash and then d dash square, d dash minus 1 into 1, that is a into b, d dash square minus b square, that is minus 1 square. So okay, the previous term is here, there is no change. We need to replace d square by minus a square, a equal to 1, so minus 1 square equal to minus 1, d dash equal to minus into a into b, a is 1 and b is 1, it is equal to minus 1, d dash square is minus b square, minus b is 1, 1 square is minus 1. So here you can check it, d square equal to minus 1 square minus 3 into d dash is minus a into b plus 2 into d dash square minus b square. So if you simplify the denominator, minus 1 minus into minus plus 3, this is minus 1 to 2 minus 2. So 3 minus 3, 0, the denominator is 0. So then you should multiply the numerator by x and differentiate the denominator with respect to d. So you can write like this, multiply the numerator by x and differentiate the denominator with respect to d. From here I will get x by 2d minus 3d dash, this is 0. Right hand side is sin of x plus y. So this is equal to 1 by 2 into, but here the problem is here, similar type of problems you faced in differential equation also. Okay, so you can't replace here by, I don't have the term d square and d dash square, then you should multiply by its conjugate. Okay, For example, if we have 2d minus 3d dash, we should multiply and divide by 2d plus 3d dash. So make it the denominator in the form of d square and d dash square. So multiply and divide by this term. So then the numerator is 2d plus 3d dash d dash. The denominator is what? 4d square minus 9d dash square into sine of x plus 1. So again you need to do the same procedure. D square equal to minus 1 square. There is no d dash term. So d dash square equal to minus 1 square. So you can check it. X by 2, 2d plus 3d dash divided by 4 into minus 1 square minus 9 into d dash square is minus 1 square. So x by 2, 2d plus 3d dash divided by, this is minus 4. This is minus into minus plus 9 into sine of x plus 1. The denominator will have 5 here. So 5 into 2, 10. So 2 times should differentiate this. 2 into, you know that d equal to dou by dou x. So you should differentiate partially with respect to x. Keep y is constant. So then you'll get 2 times cos of x plus y. The coefficient of x is 1. So into 1. Similarly, plus 3 into d dash of sine of x plus y. So you should differentiate partially with respect to y, and you keep x is constant. So 3 into cos of x plus y into, if you differentiate y, you'll get 1. So x by 10. So this is 2 times cos of x plus y. This is 3 times. So 5 times cos of x plus y. So if you cancel 5 and return, you'll get x by 2 into cos of x plus y. Okay, next we need to find PI2. Okay, what is PI1? And we'll check it. This is PI1. So PI2 is what? 1 by 2 into 1 by d square minus 3d dash plus 2d dash square into sine of x minus 1. So PI2 equal to, please check it, 1 by 2 into 1 by d square minus 3d d dash plus 2d dash square into the right hand side function is sine of x minus 1. Okay, here again you should replace d square by minus a square, that is minus 1 square, and d dash by minus a into b, minus a is 1, b is minus 1. So this is equal to 1, this is equal to minus 1. D dash square by minus b, b is minus 1 square, so minus 1. This is equal to 1 by 2, 1 by d square is minus 1, minus 3 into d dash is 1, plus 2 into d dash square is minus 1 into sine of x minus 1. So this is equal to 1 by 2 into 1 by minus 1 minus 3 minus 2 into sine of x minus y. So here you have minus 6. So minus 6 into 2 minus 1 by 12 into sine of x minus y. So the general solution is z equal to CF plus PI1 plus PI2. Okay. So and then one more column. Problem number, I don't know problem number. Okay. And right. So d square plus d dash square into z equal to sine 2x into sine 3y plus 2 into sine square of x plus y. Okay. Now, so solution of, so first you need to find the auxiliary equation. So the auxiliary equation is m square plus 1 equal to 0. So this implies m square equal to minus 1. This implies m equal to plus or minus I. So the roots are distinct roots. So and hence the CF is m1 equal to I and m2 equal to minus I. F1 of y plus ix plus f2 of y minus ix. So pi1. So you can solve this problem in two different methods. One is a shortcut method because here you have both the terms are sine and sine. There is no d dash term. So now I am going to use a shortcut method. So if you want to verify this method, you should use the original method. So for this, you should use the formula 2 sine A sine B. So you know that 2 sine A sine B is cos of A minus B minus cos of A plus B, and then you should find PI1 and PI2. You can do and verify later. So PI1 here 1 by d square plus d dash square into sine 2x into sine 3. So replace d square by minus a square, that is minus 2 square, d dash square equal to minus 3 square. So 1 by minus 2 square plus minus of 3 square into sine 2x into sine 3. So this is equal to 1 by minus 4 minus 9 into sine 2x sine 3. So the final answer is minus 1 by 13 minus 1 by 13 into sine 2x into sine 3. So using shortcut method, we got the answer quickly, but it is better to do by original method. Please verify later. And this is PI1 and the PI2. Okay, PI2 is 1 by d square plus d dash square. The right hand side function is, what is the right hand side function? 2 into sine square of x plus y. Okay, now this is equal to 1 by d square plus d dash square 2. Okay, so you can write sine square theta equal to sine square theta equal to 1 minus cos 2 theta by 2. So 2 sine square theta is 1 minus cos 2 theta. So this is equal to 1 minus cos 2 theta is x plus y. So this is equal to, you can split into 2 power d square plus d dash square into 1 minus 1 by d square plus d dash square into cos of 2 cos 2 into x plus y is what? Cos 2x plus 2y. So you can do the first part in 2 different methods. So I will use the shortcut here. The latter case you can write, there is another method is also here. So you can take d square commonly. You should write the denominator in the form of 1 plus x, then write in the numerator, and using binomial expansion you should expand it, and then you need to simplify further. But I'm going to use here also a shortcut method. So this is equal to 1 by d square plus d dash square. You can write 1 is e power 0x plus 0y minus here, this is comes under type 2. You should replace d by minus a square, that is minus 2 square. So minus 2 square d dash by minus b square minus 2 square into cos of 2x plus 2y. Okay, now you need to replace d by 0, d by a is 0, and d dash by b is also 0. So denominator is 0. 1 by 0 into e power 0x plus 0 minus, but here minus 4, so minus 8, so plus 1 by 8 into cos of 2x plus 2. But here you have 0. So you should multiply the numerator by x and differentiate the denominator with respect to d. So x by 2d x by 2d into e power 0x plus 0. And 1 by 8 cos of 2x plus 2. By 8 into cos of 2x plus 2y. Okay, now this is equal to x by 2 into. So here I am going to do, even you can do like this. Here also just replace d by 0. So if you get the denominator 0, you can multiply by x. So x square by 2. Or if you differentiate 2d, you'll get 2 x square by 2. So that is one method. Otherwise, 1 by d of this is 1 plus 1 by 8 of cos of 2x plus 2y. So this is equal to, so if you integrate, this is actually d is differentiation. 1 by d is integration. You get x square by 2. Otherwise, you'll do one more step. So x by 2 into x plus 1 by 8 into cos of 2x plus 2y. The final answer is x square by 2 plus 1 by 8 into cos of 2x plus 2y. This is what PI. So the general solution is z equal to CF plus PA. Okay. Now I'll give one practice problem. So try to get the answer for the practice this problem. So dq minus 3 d dash square plus 2 into d dash q into z equal to e power 2x minus y plus e power x plus y. So try to get the answer for this problem. Okay. So if you have any doubts, you can ask to me. Actually, tomorrow I have a valuation, so it is a little bit difficult to take the first hour. So I think again Friday second hour, if you are, I think you are free. Can I take Friday second hour, coming Friday second hour instead of tomorrow first hour? Okay. So okay, thank you. If you don't have any doubts, and one more thing I want to say, because here I am I don't know whether you are practicing the problems, because all the problems are I am working here. But in the classroom, usually I will not do like this. So I will solve only 80% of problem or 75%. Remaining 20 or 15% of problem, the students should practice. But here I am doing each and every steps. But you are watching, I know that. But you easily forget the ideas. So please try to practice the problem. So then only you can reproduce in the final exam. If the final exam is online, no problem. So everybody knows that. If it is offline, surely you will face the difficulty. So please practice in your notebook. Okay, thank you.